Guys, welcome back. So what we're looking at today is lesson 15, estimating population measures of center. So we have 3 different TV shows. Here are the ages and years of a random sample of 10 viewers for 3 different television shows. The shows are titled Science Experiments You Can Do, Learning to Read, and Trivia the Game Show. Calculate the mean for one of the samples. Make sure each person in your group works with a different sample. So obviously we're not going to be in a group, but we will find the means of all of these. So the mean of sample 1, if we add these all together, so 6 plus 6 plus 5 plus 4 plus 8 plus 5 plus 7 plus 8 plus 6 plus 6, we're going to get 61 divided by 10 because it tells us there's 10 viewers. So we end up with 6.1 for our mean. Now sample 2, 15 plus 14 plus 12 plus 13 plus 12 plus 10 plus 12 plus 11 plus 10 plus 8 is going to be 117 divided by 10, which gives us 11.7. And then the last one, 43 plus 60 plus 50 plus 36 plus 58 plus 50 plus 73 plus 59 plus 69 plus 51 gives us 549 divided by 10, which is 54.9. So there are different means. So which show do you think each sample represents? So based on the ages and what these TV shows are called, learning to read. Learning to read probably means that we're going to be looking at a younger age group. We're going to be looking at some fairly young ages, so we want the lowest mean. So sample 1, learning to read. Now, science experiments you can do, probably going to be geared to teenagers, so kind of in the middle there. So our sample 2, 11 years old, that'd be the age where you want to experiment doing all sorts of science experiments. So science experiments. And then last but not least, sample 3 is going to be the trivia game show. A lot of older, it's geared more towards an older age. They want to try the trivia. They're going to have more of the knowledge to be able to play the trivia. So trivia game show. All right. Who's watching what? Here are 3 more sample viewer ages collected for these same 3 television shows. Calculate the mean for the samples. So if we calculate the means of each of these, so we have 57 plus 71 plus 5 plus 54 plus 52 plus 13 plus 59 plus 65 plus 10 plus 71. It's going to give us 457 divided by 10. So we end up with 45.7. The next one we have 15 plus 5 plus 4 plus 5 plus 4 plus 3 plus 25 plus 2 plus 8 plus 3 is going to give us 74. Divide that by 10. We get 7.4. And lastly, 6 plus 11 plus 9 plus 56 plus 1 plus 3 plus 11 plus 10 plus 11 plus 2 is going to give us 120 divided by 10, which is going to give us 12. So we still have the same shows. So the trivia game show, the learning to read, and the science experiments. So which do you think each of these goes with? So sample 4 definitely has the oldest age. So sample 4, trivia. The youngest is our 7.4 here. So sample 5 would probably be our learning to read. And then sample 6 is that one that's right in the middle, kind of teenager range. So it'd be our science experiments. So for each show, estimate the mean age for all the show viewers, so we're using what we had from before. So learning to read 6.1 plus 7.4 is going to give us 13.5. Divide that by 2, which gives us 6.75, so about 7 years old. So then science experiments, we have 12 and 11.7, which is going to give us 23.7 divided by 2, which will give us 11.85, so about 12 years old. And then 45.7 plus our 54.9. 45.7 plus 54. It's going to give us 106. And then we divide that by 2, we get about 50 years of age. So calculate the mean absolute deviation for one of the show's samples. Make sure each, obviously, we're not going to do all of them. Well, we won't, groups. But if we calculate the mean absolute deviation for learning to read, so looking back at this, the learning to read was the 6.1, finding how far off each one of those is. This would be 0.1, 0.1, 1.1, so on and so forth, adding that all up and dividing by 10. We're going to find that it's 0.94. In the second one, it'd be 5.16. So in the second set of data, it's much more spread apart. So we don't have quite that same consistency in our values. For science experiments you can do, that was samples 2 and 6. If we calculated the mean, we'd find that it's 1.56 and 8.8. And the last one, 3 and 4, were 8.9 and 21.82. So we had some differences. The mean absolute deviations were very different between them. The first set of all of our game show data, the values were much closer together. In the second set, there was a lot more variability, and so that's why we have such large mean absolute deviations there. So for 5, it tells us how spread out the values are. So how spread out values are for each sample. For 6, an advertiser has a commercial that appeals to 15 to 16-year-olds. Based on these samples, are any of these shows a good fit for this commercial? It might work best with science experiments you can do, but since the average age is about 12 years old, there may not be many 15 or 16-year-olds watching this show, so maybe science experiments, mean age 12, but might not have many 15 or 16-year-olds. Might not have many 15 or 16-year-olds watching. So this kind of shows you how our measures of center, finding the mean and median and all that, measures of center is your keyword, by the way, measures of center, vary depending on the set of data that we're given, because obviously even though our mean was very close, our means were pretty similar between each of them, the deviation from the mean was very, very different depending on the set of data. So we have to be careful with that. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.